Okay, so again, the points of the vertices of the triangle are adjustable according to what you enter here. The centers can be moved around. X coordinate of the center, first center, Y coordinate of the first center, X coordinate of the second center, Y coordinate of the second center. And then angle 1 will grab the triangle and rotate it about center 1. And then until it's where we want it to be. And then center 2 will grab it and rotate it about center 2. And this will work even after you change the centers and change the vertices. So it looks daunting, I know, but what do you do when something looks daunting? What's the strategy to get started? Yeah, fine. So what's something that we can maybe maybe it seems like a simpler task that will help us get towards this goal. So what's getting rotated here? Yeah, and more specifically, what does the triangle consist of? Like in terms of, yeah, so it's got 3 points, the vertices, and also the line segments joining those, right? So if we could think about the simplest task we could think of related to this, to get started, what might the simplest task be? Just getting what? Doing what? One single point. Okay. So we could do one point around one of the centers, or we could even simpler than that. That's the right idea. What could we do? Well, so I think you know how to do that. Right. You can, yeah, you guys, that's just segments and points, right? So the triangle that's old hat. So
which point is being rotated?
Well, so we're talking about a starting with an easy task. So Leo suggested just rotate a point around a center. And so how could we make that even easier to start with? So this is definitely on the right track. We could do it even easier than that. Rotate a point. Any particular center that would make it easy? Origin. How about the origin? So let's rotate a point about the origin. So that's what this file does. So you enter a starting point. And then I've got this this variable called angle, and I made it a slider. And so then when the slider is set to 0, we're just talking about whatever that point is. And then as the angle increases, as you increase the angle with the slider, it will start to rotate counterclockwise around the origin from the initial point. And then when you get to 2 pi, it'll be back to where you started. So really we have this point. So rotating it about the origin is going to have to do with what kinds of things? Like how can we start maybe framing the geometry of this? Okay, how could we start?
I know I just finished up our calculation unit at my internship.
Okay.
But we didn't do all of the different degrees. Like if you did 90 degrees counterclockwise, it was like the rule was y negative x.
Okay.
But obviously, like something that simple is you're gonna have to do a little bit more difficult.
Yeah. So maybe that would be something like we could check what we come up with, right? Because that's just a specific case of So what you learned for those specific cases, ours should definitely work for those. So let's change the point here to maybe like 3, 1. So what might we do to start framing this? So they're starting at 3, 1. So yeah, so when I change the point to 3, 1, now this at angle 0, it starts at that point and takes me around. Okay. Okay, so certainly the radius seems important. What else? So really we've got the starting point, and then we've got all these possible places that we could go. And so what we could kind of like pick an arbitrary one and say that just this point now represents every other point that the point could go to, right? And so let's just be generic. We're not going to actually say, oh, that is the point, 1.9, 2.7. We're going to say this point represents any point for any angle swept between 0 and 2 pi. So keep going. So what should we do? Trying to figure out how to plot. I mean, what we want is how to plot that point, right? In the end, we need the coordinates of that point, right? Ideas? Yeah, sure. All right, maybe a parametric function. Okay. So how can we get there? So how can we get from, if it is a parametric function?
Use how the coordinate points are placed with r cosine theta and then r sine theta.
Okay, so she's saying the coordinates, so as we're rotating about a radius around the origin, that x being r cosine theta and y being r sine theta might be helpful? Is that? They confirm that? That x equals r cosine theta and...
Oh, we know that.
What's that?
Oh, we know that.
Did you get confirmation?
No.
Okay. All right, so what else? What about the radius for this point? It'd be the same. Okay, so what about the angle? How does that come into this picture?
Well, it's increasing or it's changing that's what we need to figure out this because that's what changed from the red dot to the blue dot.
So what changed from the red dot to the blue dot is the angle measure.
Yeah.
So how could I label that in the graph? Or in the picture? Theta. And theta is from where to where?
From the x-axis to the y, or to the,
So from here up to here?
Yeah. That's the theta.
That's theta?
Yes. That's the angle.
It's that minus the smaller angle.
Okay, so we've got something called theta, and we have something called angle. So talk at your table. What are those? What is theta, and what is angle relative to this picture? Go, discuss it. So what is theta, and what is angle? Now looking at this picture. Right?
From the red dot to the blue dot is the angle. Isn't that theta? It's just a dummy variable. Right.
But what angle measure is it? So that's what we're saying.
So for this particular one, it's angle.
Okay, so quickly quiet. What did you guys come up with?
We said that angle was the angle measure in between that bottom radius line you have to the red dot and the top one is the blue dot.
Imagining like from here to here like this?
Yes.
She's saying that is what I'm calling angle in the GC file. The measure, that measure. Brandon likes it. Agree? Rachel likes it. Eunice likes it. Okay, yeah, that's angle, right? Okay, so then what's theta? What is theta? What did you guys talk about? Anything? So is that the same? I mean, so is x equal to r cosine angle and y equal to r sine angle? Is that the same thing? Just saying yes. Was that Alejandra?
Is theta the difference between the angle measurement on
Kind of. I think what you're describing is angle, right? You're saying it's the difference of something. So I think just kind of crisscross. What is angle and what is theta?
So angle in the GC file is the angle measurement with respect from the original dot,
Right.
the new dot.
Okay.
And then theta that we're talking about is the new point with respect to the x-axis.
With respect to the x-axis. So theta would be this. That's theta. Anything else to add? So you talked about a difference. You said, what is the difference? What is the difference of what and what?
It's the space or value between.
But what variable or what quantity is the difference between what other quantities instead of just what you're seeing on the screen? Is that hand over there? Or just a stretch? So yeah. So what is the difference of two other things? Does anyone see it? Yeah, Jesus. So you're talking about another theta. Is there more than one theta? Yeah, stick with it. You were doing good. Yeah, there's two thetas, right? There's a theta for what? The given point, in this case it's 3, 1, but it could be anything, right? So like theta, it's theta A, right? Theta the point A. And then there's the theta for the actual variable point, right? Which is all the way down. So what is the difference of what and what? So put it all together. I'll just call it theta. That's variable, right? Yeah, you could say that. You could say theta minus angle equals theta A. Or maybe yeah, so maybe that's a little more natural to express it that way. So this is perfectly right. Maybe it's a little more natural to express that, right? The difference of our angles to the x-axis would be then the angle between those two terminal sides, right? Or the angle. Okay, so we're making progress, right? We're conceiving this. What's going on here? I'm not sure. Kylie, what do you think? The goal in the animation is to find angle A. The goal in order to build the animation would be find angle A. Okay, right. So this she's asking this angle right here, this measure, that A, is that the same as angle right here?
So
Is it? Hold on. So yes. Okay. So
we're trying to figure out how to do the points. We're trying to figure out how to get x2 and y2.
she's saying we're trying to figure out how to get x2 and y2.
Or at least to show them on the GC file. Yeah. Because we're given x1, y1, that's A.
Right.
And then the slider is the angle.
Okay.
And so then it shows us x2 and y2.
Everyone agree with that? Yeah, so the user enters in that coordinates at that point. The user chooses on the slider what that is. And then what does GC come back with? GC comes back and gives us this point, right? Okay, so we need to use GC or use mathematics to write the coordinates to that point. Once we get the coordinates to that point, then it's just a matter of entering that mathematics into GC. So we need the coordinates of x2 and y2. What's that? Someone say something? Coordinates of x2 and y2. Yeah.
I think it wouldn't it be 3 cosine angle and then 1 sine angle?
Okay, so we want to do it generically, right? So we want to, so really, this is point A, right? So yeah, that's the right idea, but instead of using 3 and 1, we want to use x1 and y1. So we agree with what she said? What did you say? 3 cosine theta and 1 sine theta? Is that what you said?
Yeah, but I'm trying to figure out more generically now.
Others? So those on computers, are you working hard on this? Is that what you're working at? So I don't want you to try to create the GC file. We gotta do the mathematics first. It's a little bit involved. We've got some things to do. So it's not about just kind of guessing with some trig stuff. We've got some stuff to do. So let's yeah. So I'd be skeptical that you could come up with this just writing a GC file now. So Leo. So maybe I'll just suggest that we call this angle something right here. So what should we call that? If this is A, maybe just this is our theta, okay? Even though before I said theta was variable for x2, y2, let's make our theta this angle here to our given point. So now we want to figure out what x2, y2 is. Anybody can get us started on x2 and y2. Is that a hand? Who was first? Oh, go ahead.
So, since the radii are the same,
Okay.
then we can find the radius from the origin to x1, y1.
Okay.
And then apply that to x2, y2.
Okay.
And then the angle is a plus theta. So we have r times cosine or sine theta plus a.
Okay, so she's saying x2 is equal to r times cosine of theta plus a. Autumn, is that a nod? Eunice agrees. So let me just write that down and see if everyone agrees. So x2 equals, she said, r times cosine of theta plus a. Agree or disagree? Kylie likes it. Brandon likes it. Karen likes it. So yeah, so the x-coordinate of a point, right, is going to be the radius times the cosine of that angle. Okay? Keep going. So what else could we write now?
So then you can do the sine part, because sine is going to be the same thing, but with sine.
Okay, but what are you finding when you do all that? What, y2, right? Y2. We do y2, and that equals? So it seems like a good start. Why? Because it's defining the things we're trying to find, right? We're trying to define what x2 and y2 are, and I think we're confident that it's defining those things correctly, according to the way we set up our diagram. Is that right? All right, cool. What else can we do? Okay, we can find the radius. Let's just hold that off. So, what is the radius?
There's the square root of x1 squared plus y1 squared.
All right, so can I just write that up here? And we'll just keep it there and avoid injecting kind of that ugliness until we need to. How about that? Is that okay? We'll just hold it as R. So we know that R is that. We know it's that. But let's just hold it as R and see what happens. Yeah, Kylie.
Wouldn't it be plus y1 squared?
Probably. Did I miss here or did you misspeak? I don't know. Doesn't matter. Okay, are we good now? Yep, that's right. Okay, what else? Any ideas? So x2 is dependent on what? So x2 and y2 are dependent on what?
Our theta and our A. Our theta and our angle.
Okay, but like at the very baseline of this thing, where?
The first point.
Yeah, so really, we know that we're dependent on that and that. So we know this x2 and y2 is going to be written in terms of a and x1 and y1. What's missing here? Yeah, so could you write what those are? Go. Can you write what those are? Should be able to. All right. Kelly, did you get those? You doing something else? A different part? How about, what's that? You're just working on it. Leo, did you get those? Sine theta? Okay. Okay, so again, what's our goal? We're trying to write x2 and y2 in terms of a and x1, y1. What can we do now?
Get something for
We have
theta.
to change theta. We can't have it as theta. We have to put it in
But what if we, how about this? What if we had x2 in terms of cosine theta or in terms of sine theta? Then we wouldn't need theta, right? Because that's what we've got. Rather than trying to pick off theta, can we just keep it in working in cosines and sines? So cosine theta, sine theta. So how could we get x2, say, in terms of cosine theta? Looking at this.
R cosine.
So cosine is distributive.
Yeah.
Cosine of the sum is the sum of the cosines. Is that right?
I don't know. I don't remember.
There's a trig identity.
Yeah.
Trig identity.
I don't remember what it is, but I think there is one.
I think it's cosine theta times cosine A plus. I don't remember. But it had two specific. It divided the angles between
Okay.
two different trig functions and added some.
So will it get x2? So before we write all that out, will it get x2 when we write out, if we do the sum formula? Will it end up giving us x2 in terms of cosine theta and or sine theta instead of theta plus a?
Yeah.
Yeah. So maybe this is a worthwhile route. I mean, there's really nothing else we can do. We have r times cosine theta plus a. Just like the only thing we can do to chisel at this is maybe apply that identity for the sum. So if someone want to look it up so we don't write it incorrectly the first time? Yeah, that's what I'm asking.
It's
The-
cosine theta times cosine A
Okay.
plus sine theta times sine of A.
Did I do it right?
R cosine theta cosine A plus.
So then I just got R's out of there. Should I multiply the R in or not? What are we trying to do? We're trying to write x2 in terms of x1 and y1 and a. So should I multiply the r's in? Yes. So I'll just do, how about that? Can I do that? Does it look like it might help? Why? Why?
Because now you can rewrite it as x2 equals x1 cosine A plus y1 sine.
This is good, right? This is good. So let's do before we do that, let's actually do y2 as well. So y2 would be, that's a 2. So y2, we need the sum for sine. You got that too?
Sine of theta cosine A plus cosine of theta, or wait, which one do we do? Cosine of A, sorry. Cosine A.
That's the same. Is it the same in both?
Oh,
Sine A?
oh, sorry, I didn't know which one you did
It'd be sine theta cosine
A plus.
A plus cosine theta sine A.
Is that right? Okay. Just make sure before we go any further. Are we in agreement on that? Okay. So now we can write. We can write those more simply, right? x2 is. You do the next step. So what's x2? What's y2? So Eunice, you tell me.
X2 is equal to x1
Mm-hmm.
cosine A plus x plus y1 sine A.
Agree? Good. Who wants to do? How about Britt? What's y2? So y2 equals. Yeah, so we're working off here, and now we realize that we can get the x1 and the y1 in here now, right? So how do we get x1 and y1 into this? Y1. Cosine A. Good. Is this helpful? I mean, are we making progress toward our goal? Just kind of, or really good? This is really good progress, right? What did we say we wanted to do? We wanted to write x2 and y2 in terms of x1, y1, and a, and that's exactly what we've done, right? Now I'm gonna change the order of this. I'm gonna line up the x1s here, and line up the y1s. So can I just change these? Just x1 sine A. Are we sure we got these right? Is there maybe a problem we have in our... I think we got a formula wrong somewhere along the line. Does the sum for sine have a minus sign in it?
Cosine's minus.
Cosine of which? A or theta? It doesn't matter, right? So if we made it yeah, so I'm seeing that the cosine formula, this is minus here.
Yeah, that's what I was trying to say.
Okay. Oh, sorry. That's minus, right? So if that's minus, what's the difference here? We just get a minus here. So that was not a costly mistake. Recovered pretty fast. Okay. Are we good now? So we had the formula wrong, and the cosine should have been minus, and then that just changes x2 to be minus. So when I switched y2, that doesn't affect it because those are plus. Okay, so this construct here, does it, as you think about your higher mathematics, and your math, all the math you've had, do you see anything about that? The structure of that? It actually can be written a different way. So this whole thing can kind of be written a different way. Anyone recognize the form of that? How that could be structured a different way? Yeah.
Would it be in x1, y1 parametric, and then another parametric cosine minus sine A on top, and then on the bottom sine A plus cosine A?
Yes. So essentially, yeah. So what she's getting at is that this point x2, y2 we can think of as an entity, or in GC, right? That's the way we would define that, right? Kind of, we define that together, right, as a point. So that point, so basically, how can we write those two equations as one equation? What's the key mathematical thing here that allows us to do that? You notice what this is? Maybe if I take these little edges off, it'll conjure up something here. What's that? Yeah, this is really a matrix formula, right? The matrix, I guess we put those on matrices anyway. But yeah, the matrix x2, y2 equals what? Some other matrix times x1, y1. What is that other matrix? Remember how to multiply matrices together? So as you go across the first one, you go down the second one, go across the row, down the column, multiply and add, right? So what would be the first row?
Cosine A minus sine A.
Negative
Negative
sine.
sine.
Negative sine A, okay, and?
Sine A.
You guys have done matrix multiplication, linear algebra, matrix multiplication.
Yes.
So this is like backwards, right? It's like we ended up with these two equations that fit this matrix multiplication perfectly. Because if we were to go across this row and simultaneously down this column, we'd be doing cosine A times x1 plus minus sine A times y1, and that would equal x2. And there it is. Same thing across this row, down this column, multiplying. This is how we multiply matrices, right? sine A times x1 plus cosine A times y1 equals y2. That's that equation. So this is nice. Why? Because this is exactly how GC, how we're going to feed and get points from and give points to GC, right? So this thing is called, it's a basic rotation matrix, right? Because it's all based on what? Just the angle A, right? So that given that angle A, this matrix represents, mathematically represents that amount of rotation through angle A, right? Starting from this point. Okay, so how can we then? So we want to think about we've got the math behind this now. So we want to think about framing this for a GC file, right? So how do we frame this for a GC file? What do we want to use to do that? Points.
No, not a point format.
Yeah, points are part of it. Okay.
Is there a matrix formula you want us to know? How do you do matrices?
Yeah, we can do 2 by 2 matrix. But so like given an A, we want to have what this is, right? What's that the idea of? Leo. Given an A, we want to have something that tells us what this is. Just think of that email that had such a great impression on you, right? Function, right? So given the A, we want to write a function that gives us that matrix, right? And then another thing we could do is what? Given that result and the point, so given those two things, we could have a function that gives us the resulting point, right? So we want to construct functions here. So let's call, what should we do? Let's call capital A. So maybe we don't need particularly need a function for that, but at least let's call that something like capital A. Or no, capital A is already the point, right? It's like capital A.
So we have to
Call it-
that matrix.
Call it capital M for rotation matrix, okay? So we're going to do M.
Equals a matrix.
Right. And that matrix is going to be, so let's see here. How do we do 2 by 2 matrix? I think there's in the menu.
It's Control Shift 2.
Control Shift 2. So Control 2 gives you a 2 by 1, so Control Shift 2 gives you 2 by 2. So this is appropriate use for a parameter for M and not a function. Why? So why? So why might we need a function versus just a parameter? So this would be what? Cosine of, so in my file I called it what? Angle. And then anymore. If you want to call it A, if that's simpler, let's call it A, that's fine. So that's what I'm asking. Should we do m of angle or just call it m? So for instance, when you did your the left x thing, some people did a function left of x. Other people made a parameter left x. So there's situations where one is appropriate and the others are more appropriate than the other. So what's appropriate here? Do we want to do m of angle, or do we want to just say that whatever the value m is this matrix based on what angle is? This? Why? What's that? For the ease of it? Is that what you're saying? Yeah, so it's easy when you write this, but will it be the easiest when you finish a file, right? So when you're doing a long file, will it prove easier to not have it as a function? So that's the key. That's the question. All right, what else do we need? So what I wanted you to kind of try to work on it now, so I think you can do it. So let's call the function that gives the point x2, y2 is going to be the function named r. Okay, when you define a function, okay, remember when you define a function, these are dummy variables, right? These are dummy variables, and you don't have to use, sometimes it's helpful not to, use the actual variables of the actual quantities in the file. Does that make sense? Sometimes it's nicer to choose something different, and then when you call to use R, you're going to then use the actual variables that we called, for instance, so like m or angle or whatever. Okay, so just remember that you don't. When you're writing a function, you can use any letters that you want to define it, and then later when you actually use the function and use the function notation, then you're going to insert the actual variables and parameters in the rest of the file that have the meaning. Okay, so why don't you work on it? So work together, and as much as you can, use forethought and think about it rather than guessing. So can we finish this now? So we have this relationship. We've got the matrix times we've got that relationship. So can we finish the file so that we get this point to rotate around the origin, given any point that you choose for the start? So rather than say it's going to be r of x because that's where all my functions are. So it's what is it? So what is r going to represent, and what do I need to get that? Right. So first of all, what is that going to represent? So what this function r of something, what will that give? Is that going to give a value? Is that going to give, what is that going to give? And then, because when you write a function, you have to have an end goal in mind, and then what is it that I start with that's going to give me that? So what is the end goal? So so when I write this function, what is that going to be? What is that going to represent? But so rather than, all the functions I've seen in the past are of x, so I'm going to make it of x, you think, what do I want, right? So rather than, it's going to be r of x because all functions are r of x, what do I want, right? What is this going to mean in the end, and what's going to be the independent thing or things that's going to give me that in the end? So it really has nothing to do with x. It has nothing to do with x.
Yeah, I just use it because it's first variable.
So instead, but kind of what it indicates is that you're not really thinking about what these things are, right? So what are these things or things? So it's what? X2 and Y2. Is that right? So the independent quantity of this is X2 and Y2 of this function. Not right.
Oh, what?
So before we talk about the independent, let's talk about the dependent. What do we want the function to give, right? So this R of something, right? If we're talking about a function, that's the result. So we're thinking about this thing as a machine. R of something is what the machine spits out. And what, in the end, we want the machine to spit out? X2, Y2. X2, Y2. Okay? And what are we putting in? So what does R need for us to give us X2 and Y2? Angle. Okay, but we've kind of, so it does need the angle, but more simply, we've already kind of defined the idea of the rotation, which is what we called what? M, right? Is that all it needs? Does all it need the rotation M to give us X2 and Y2? So if it just has the rotation, then it can give us the final point? No, what else does it need? What else does it need? Right, the initial point. Okay, so maybe we can come back and say, all right, let's call that X. The initial point, let's call it, may say capital X. So if we had M, which represents this matrix of the rotation matrix, and we had X, which is like representing our initial point, then put those into this R function, and then it should spit out this thing. So we can do R of M comma X. We're defining the function now, right? So again, dummy variables. We don't have to use M, right? So we can use something else, B. So we're going to say B is going to be that rotation matrix, and X is going to be that point. So what would be the rule that's going to give us the X2, Y2? So what's the rule? No, not M times A.
It works. What do you mean it's not it?
Okay, I'm using dummy variables B and X. So M times A is not going to work if I do R of B comma X, right? So if you got it to work, that's great. I applaud you. But I'm not saying that you're wrong. I'm saying if we set up this function as R of B comma X, M times A is not going to work because I've chosen dummy variables B and X.
So B times X because you're going to input M into B and A into X.
Right. So the definition of the function would be this B, which we know is our rotation matrix, eventually. And X is going to represent my initial point. Okay? So now, how am I going to graph? Now I want to use the function. So this is the definition of the function. And now I want to use the function. Right? So I want to use the function to express the final point. How will I use the function to express what the final point is? So, the final point x2, y2. How can I express the final point x2, y2? final point being the dependent thing in this function. How do I express the dependent thing in a function?
Do you mean like having just x, y is equal to r of, and then put m and a?
Yeah, but you don't need the xy part. So if I just want to express, I just want to say, here's the dependent thing. What is it? That equals r of m, comma, a. And you're done. What does that do? That is, so now it's what's going to do. It's going to say, oh, you want me to take m, substitute it for b, and a, and substitute it for x, and find out what I get when I multiply them. And that will be the point, x2, y2.
Isn't that going about it the long way? It's less code.
I'm trying to teach you something that's really powerful in mathematics. When you have a long, complicated animation file, if you're not using this, you're going to be at a big disadvantage. So this is a simple file, yes, that you can do it more simply maybe in fewer lines. But when you have something complicated and you're using a rule over and over again, to define a function and use a function is really, really important, and to be able to think this way. So yes, I love the easiest way too. And I'm trying to tell you, when things get harder, this is the easiest way. Do you buy that?
Because we could have different A's and we could have different B's, so we want to just, so if we had B and X and arbitrary.
Right, so suppose you had to do 3 different starting points.
So then we can plug in what that is.
See?
And this is the extra credit one, or is this the
No, this is our
one that's actually
Yeah, the extra credit one is the rate of change in accumulation. Okay, does this make sense? So again, B and X mean nothing except for how they're structured in the rule, and then when we come and use it, then we're going to say, okay, I want what we've defined as M to be there, and what I've defined as A to be there. It's going to multiply them and give you, and that just that statement right there should plot the point, because that's what it is. It's a point. When you multiply the 2 by 2 by the 2 by 1, you get the point. Right. So if there's this rule, so that this rotation matrix times the point, is you're going to use it over and over again, then this is going to be really helpful. So I have a little bit different in mind. Did everyone get this to work somehow? Questions? Do you have a question?
No, I got it.
Oh, you got to work. Good. So I just used x and little a. So, and I put the capital X first, okay? So if I put the capital X first, then when I use it, I got to put the point first. And then I said little a was just the angle, and I put the rotation matrix into the rule for an angle A, and then I just called R A, angle. So there's a different way to do it. Does that make sense? So instead of defining, I never defined an M, and I just put that matrix in the function rule using the dummy variable A and capital X, and then when I call on capital A for the point and angle for the A, it plots the point blue. Okay, questions? So then, okay, go ahead, Autumn. So let's try it. So let's just do one more point. So what do you want? So point B, make it say 2, 4. Here. Okay, so then what would I do? So now I've got another point. B is a different starting point. right? So what would I do if I want? What if I wanted a different angle for that one? What would I need to do? Create another slider. Let's do that. So call it angle. I don't know if you can do numbers and letters together here. Oops. You can or can't? So angle. Okay, go slow, Mark. How about that? All right. So calling on the same function again, but now I want the point B and I want my second angle. So let's see if it works. What's it going to do? So here's for angle and point 1, 3, 1, and then now the second angle for point 2. I just didn't graph the first point though. I never graphed the initial point. Good, nice. Autumn, did you bring that up? Does that make sense? What's that? We're rotating about the origin. The radius can be anything. The radius is defined by the whatever your initial point is. But yeah, this only works for rotating around the origin. So next step is to rotate it about some other point rather than the origin. That's the next challenge. So took longer than I thought. But any questions? Yes, sir. Yeah. Yeah, it's all recorded. Okay, so yeah, so if we could get the corresponding function for rotating about, so if we could get this for rotating one point around another point instead of around the origin, then you'd be home free to finish this, the triangle project. You'd have everything you need. It's a little bit tedious at first, but then once you see the pattern, then you just type it all in. Okay, so that's the last thing we need. Now we need the same thing for rotating about any point, not just the origin. So that's your goal for the weekend. Can you do the mathematics for rotating around any point? So we're going to start afresh, right? We start afresh with a diagram like this. That starts from any point. Call it XC, YC, right? Starting from any point XC, YC, rotating a second point around that. So we want to start from scratch. Try to work through the same mathematics that we worked through. It's really similar, but you just have a couple, it's a little more complicated, but not much. Because you have, instead of 0, 0, you have XC, YC. Okay, so center, for center, C for center. All right, so you're working on your project, and then that's for Tuesday. Just that, not finishing the GC file, but just the same mathematics we did in class today, but for a center other than the origin. So I don't recommend just going into GC file and guessing, like changing the function and guessing what it would be.